content. Dan, are we good? All right, man.
Okay.
It's all you.
Hi, well, it's great to be here. I'm in California for a couple of weeks and took the opportunity to come speak here, which is really exciting. So this talk is about Spock, but it's kind of not an introduction to Spock at all. It's assuming you know the basics. So I'm not going to be sitting here telling you about how given when then blocks work and how to make assertions in Spock and all that kind of thing. So it's going a little beyond that. It's not super complex, but it's really about, let's look at the difference between the basics of knowing how to use Spock and how to use it nicely, how to produce tests that are really readable and maintainable and will stand us the test of time. Some of the examples are on GitHub. There's a URL there that takes you to GitHub. Most of the code samples you'll see on the slides are based on something in that project. So by all means, if you're interested, take a look. So let's get started. One of the key ideas, I guess, that I want to get across is that I look at tests as documentation. It's not a new idea, I don't think, but it's kind of that tests are executable documentation. They can't go stale the way a Word document does, a technical spec does. They can't. One of the guys at the company I used to work for, Gus Power from Energize Work, calls a team wiki the place that information goes to die, and I think that's often very much the case. That can't happen if you're maintaining your test suite and keeping it running using CI appropriately and so on. It can't get stale because it will fail, and then you know to do something about it. So it's kind of looking at tests as a form of documentation is a key thing. And one of the things that this means is that naming things is really important. And I don't know if I care about this more than a lot of people because my background, I have a degree in English literature. So how I ended up as a coder is a whole other story. But yeah, the kind of the grammar and the language of testing is something that I care about quite a lot. And here's a nice quote that kind of sums that up pretty well. Probably you may have seen this before. It's quite a famous quotation. That programs are for people to read and only incidentally for machines to execute. Or a better way of putting it is this, I think. Always code as if the guy who knows who's maintaining your code is a violent psychopath who knows where you live. There's nothing worse than coming onto a legacy project and having to deal with somebody's terrible code base, like awful or missing test suites. So we're going to look at some of the things that you can do to make tests, write tests and specifications that kind of read well and explain what the code is doing. If you're at all familiar with TDD, which most people are, I guess, you've probably seen this concept of red-green refactor. So the idea is you write a failing test, you write just enough code to make that test pass. Then while keeping that test passing, you refactor the code so that it's a hygienic, habitable code base. I kind of like to add in an extra thing here. And this idea comes from a book called Growing Object-Oriented Software, Guided by Tests, which is written by a couple of guys from London called Steve Freeman and Nat Price. It's kind of the London School TDD. They're the kind of leaders of that movement.
Can you guys hear him now? Okay, the microphone was all the way down.
I'm sorry.
No.
I'm sorry about that.
Can you guys hear that now?
Do you want me to go back at all, or are we?
No.
So the idea was you write the failing test.
It's
you write
still the
enough
same.
code.
It's still the same. There's a microphone, I think, in the stand there.
Do you want me to clip something on?
Underneath the computer, there should be a clip on.
How's that?
So go to few chapters.
That's it.
Okay.
Sorry about that. Thank you.
No, that's okay. No problem. How's that? Is that? Oh, okay. I can hear myself now, which I guess is a start. So red-green refactor is the typical TDD approach of write a failing test, write enough code to make that one test pass, then refactor into a hygienic, maintainable code base while keeping that test passing. And you go, this forms a cycle, and you go round and round in this loop. Steve Freeman and Nat Price, who are kind of the founders of, I guess, what's popularly known as the London School of TDD, wrote a book called Growing Object-Oriented Software Guided by Tests, and they kind of emphasized an extra step here that I think is really important, and something I like to think about, which is you write the failing test, then you ensure it's failing for the right reason, and that when it does fail, you can tell what the hell is going on. So the diagnostic information is clear and useful. You know that the test is failing and detecting the correct type of regression when it does fail. So it's almost like thinking about red, amber, green refactor. So this step's really important, making sure that you get the correct information when the test is failing. And I think this is one of the key reasons that test driving is really useful, that you have that failure up front. You start with a failing test, so that then you can emphasize this step of producing good diagnostic information. And for this reason, I kind of think of the prime directive of testing as never trust a test you haven't seen fail. This is super key for everything that I do with TDD. Don't assume that a test will correctly detect a regression. If you write the test afterwards, don't assume that it's going to detect the regression correctly. It might fail for a completely different reason. It might not fail at all. It might just look like everything's working fine and actually the code is completely broken. It might be unnecessarily hard to figure out what is wrong if it does correctly detect a regression. So even if you're not test driving, the key thing I think is to break the code so that you can see what happens when the test fails, and make sure that it does fail for the correct reason and does fail at all. So getting into some specific Spock things here. Spock provides a lot of annotations that are kind of purely for documentation purposes. But they're kind of interesting because they go beyond what comments do, because they're retained in the bytecode that's generated, right? So they're not, and the information that's in those annotations is retained in the bytecode. So you can use these things for like documentation generation tools and that kind of thing. So, it's not thrown away the way a comment is. Let's look at some examples here. I hope this is clear enough with the syntax highlighting. So one annotation I use an awful lot is subject. So that just says that this variable or this field, typically it's on a field in the test, but it can be on a local variable if you're setting those things up in each individual test. It just says this is the object under test, this is the thing we care about in this situation. You can use it at a class level to say this is the class that this test is dealing with. But it's really handy just to separate it out from any other things you may be setting up. Issue is quite a nice one for tying things into your issue tracker. So GitHub in this case. C is nice for tying things into kind of external documentation sources or references. Title is a new one, I think, in Spock 1.0 snapshot that is really just to give a readable title to the test instead of the typical camel case specification name. And then there's another one called narrative, which is, for the typical kind of, I'm not a big fan of this style of kind of writing, develop user stories, but it's used quite a lot, and that's the intention of the narrative annotation there. All of these, as I say, so these strings are available to you in the bytecode, so you can write tools, you can write Spock extensions that leverage the information in here. It's not just discarded at compile time like a comment would be. Unrolling is really important. So if you've used Spock's where block, you'll know that you can kind of seed a test with multiple different iterations of data, and it's a very, very simple way of doing an iterative test, much simpler than the typical ways you see in JUnit. There are different ways of dealing with that. So this is the simplest possible example. Really, is you put an unroll annotation on your specification method, your feature method. And you can use hashtag variable references in the method name itself. And when the test executes, those get replaced with the actual value for that iteration, right? So that's extremely handy, produces wonderful test output. But it's not necessarily always the right thing to use. So sometimes if this method name gets really complex, I would kind of tend to move away from using the hashtags in the method name and look at moving them up to the annotation itself. Because if you look at this example, we're saying, right, translate strings to another format. That's kind of the description of the general case of what we're testing here. And and the specifics are captured in the annotation itself. If you purely had that, you've got to think about the guy who's coming along to read this code, right? So if you purely had like hash input converted to hash format is hash output, I as a reader am going to come to that and think, hang on, give me some context here. What does this mean? Here we've got a nice separation between the general case and the specific case, which is kind of geared to the generated test output, so the reports that are produced at the end of the run. So, this is the easier option, but it's not always the right option. Another way you can use unroll is to include the hashtag completions in the method names and then just annotate the entire class. And that's like the super lazy option. And great as long as your method names are still readable, by all means, do that. But I've seen people who kind of just go for this style because it's a few less bytes of source code, but it doesn't necessarily lead to greater clarity, right? So use it if it's the right thing to use. Unroll descriptions, kind of stepping on from that, is an interesting technique, I think, where you can use we'll see. So here's a slightly messy test. We're saying we can tell if a string something is an integer or not. And we're just saying, testing Groovy itself, really. So we're throwing in some string variables, ABC, 1, 2, 3, so on, and we're using a Boolean to say whether we expect that thing to be parsed as an integer successfully or not. And this is fine, but if we think about the output that this method name is going to give us, I don't think it reads particularly well. So here's an example of what it will look like. Can tell if the string ABC is an integer or not. Can tell if the string 1, 2, 3 is an integer or not. It's not super expressive. I don't think it reads fantastically well. So one thing that I quite often do, and I think Booleans is a typical case for doing this, where you can actually add a variable declaration or using just an assignment operator. You can have an extra variable or as many variables as you like in the where block that uses the value from the table in a different way. And this variable, you'll notice, is never referenced inside the body of the method at all. It's purely used in the unroll expression here. So it's just to add clarity for the guy reading the test report. That's all it's for, but it's very useful, I think, for enhancing the clarity of that test. So now let's look at the output we get from here. So here I've even moved it up to the unroll annotation itself. And again, use the kind of general case language in the method name. And here's an example of the output, and I think it reads a lot better. So the string ABC is not an integer, the string 1, 2, 3 is an integer, and so on. Just easier to read, right? That variable is never used anywhere except in that unroll annotation. Separating test data from test logic is kind of an interesting and important topic. So what have we got here? We've got a test where we're setting up a mock function of some kind. So that's probably a Java 8 function, I guess. This is RX, very appropriate, being as we're at Netflix today. So we're saying, right, we're going to stub out our stream source, and whenever anything connects to it, we're going to return an observable containing 3 values here, and we're going to assert that our callback is called with each of those 3 values in sequence. Fine. There's our mock assertion there. This is good, but we've got an awful lot of repetition here. We're repeating these values here and here, and we're also kind of mixing in. Again, something I always like to think about is the language of the general case versus the language of the specific case. And here we're mixing the two together. So the test is kind of describing general case behavior, but we've got very specific things mixed in here. And one thing I like to do here is separate out the values, the kind of dummy values that are driving the data, driving the test, into just a where block. It's not even using iteration, right? It's just purely using assignment. This test doesn't get repeated, but I just think it's a really neat way to separate out. And it's a semantic way to separate out. This is dummy data that doesn't matter. It's just a mechanism for driving the test. This is the general explanation of what the test is testing, right? So then all of this code is purely talking in general terms. So it's very logical. And this is the dummy data we're going to use to drive that. I find that you can set up a data variable up in the given block, but I think where kind of semantically explains that this is is the parameters for this logic. So now we're going to get into some kind of stylish Spock, I think, here. I like this image here. It's not rendering super well there, but he's wearing a pretty awesome 20s style gangster suit there. So refactoring with helper methods. If you've read any of Uncle Bob Martin stuff, Clean Code or Clean Coder, you'll be familiar with this idea. It's not a complex idea. Of breaking long methods down into smaller methods that are well named and so on. And I think this applies, the key point is this applies to test code just as much as it applies to production code. So like the kind of thing I really hate to find in a legacy code base is a test like this where, we go to a login page, log in with these credentials, then we're going to hit a product page and add something to a basket. We're going to assert that we're at the basket page, and then we click a checkout button, and then we assert we're at the checkout page, and we fill out some huge form without credit card details and address. And then the simple assertion is, right, yeah, purchase successful, and the mock credit card got charged. So this is just like a huge stream of consciousness, right? And this is kind of my reaction when I find this sort of thing, or I write it. I'm as guilty of this as anyone. So we can think about breaking this out into neater ways. So we can use the Spock's shared annotation to have like just really super simple data objects encapsulating some of that dummy data if we're sharing them between different feature methods. Done the same thing there. So this is kind of all the login and credit card details, and then here's the details of the product we want to test. And then we've got some helper methods split out, just saying, okay, given that we're logged in as this person and we have added this product to the basket, then when we complete the checkout, we see this message and our credit card gets charged this amount of money. So this is much more readable. Again, we're reading the kind of user level logic as opposed to the fine-grained details of every little thing we have to type into every little form. I think the example I've given here is kind of something that looks a bit like a JEB test, and I think on those kind of end-to-end tests is typically where you really see this anti-pattern a lot of just huge stream of consciousness mess. But it can be on very simple unit tests as well. So, split stuff out, and let's look at some of the ways we can share those helper methods that I've set up there, logged in as, and so on. How can we share those between classes? Because typically these things you probably want to use in more than one test class. So a common way to do it is just to define a helper class with some static members and static import them. And this works really great if they're not sharing any state. If they don't have any state, if they're pure functions, then fine. I do this a lot. Import static is great for that. Otherwise, you can look at using Groovy's delegate annotation. So this is something that happens in JEB a lot. JEB kind of delegates to, I think, more than one different delegate. So it delegates to like a browser object and a page object. So really all that means is that the members of this class get made to look like members of the specification. So you can call them without a qualifier in front. And that can be a good way to go. Another way to go if you're using Groovy 2.2 or below is to use a category class. Say I can create a category for the Spock Lang specification class that has all of those methods on it. And then I can mix it into my different specifications. That's kind of all done with meta-class magic, which is fine as far as it goes, but this is deprecated now because we have a much better way of doing it, which is using traits, right? So we can define a trait with all our helper methods in it, and then we can just implement that trait on our specification. One thing to note with traits is you certainly can't put feature methods in there yet. I'm sure Peter's working on that, and if he does, that would be super awesome. We'll see some examples of where that would really help in a little while. And I think that anything that's annotated when any of Spock's special lifecycle annotations that happens to be in the trait, any kind of stateful fields will not work properly if they're off in the trait. But if it's just simple helpers and data objects, great, it works fine. One thing people often forget using Spock, like I always try and sell Spock to people as it's a better JUnit, right? And I do an introductory talk it's like live coding showing, okay, this is the kind of sucky Java JUnit code written in Java, and look how great we can make it look with Spock. But one thing to remember is that Spock is written in Groovy, so remember to use some of the expressive language that Groovy gives you, and not just write the same thing as you would write in JUnit using Spock. So let's look at some examples on this one. What are we doing here? So we're doing some kind of DAO call to find some spaceships by their allegiance to Federation. And we're saying, right, we should get 3 results back. And the first one should have this allegiance, the second one should have this allegiance, and so on. We've got some repetition here. We need to check the size of the list, because if we didn't do that, what if there was a 3, 4, or 5 that we weren't expecting, right? We need to check that boundary condition. This is very Java-like. We can do better using Groovy's every and any are just awesome for writing Spock tests, because they return a Boolean. So every says that every member of this collection has to satisfy this Boolean condition. And if that's the case, this returns true. If not, it returns false. So here we're saying, right, every one of those methods, those members returns, has an allegiance of Federation. Much more readable. There's a little bit of a cheat here, because we really should test that there are more than 0 in here, because I believe every will return true for an empty collection. But if we look at the output from this, it's kind of interesting. We can go further from this. You'll notice we've got, inside of the closure, we've got it.allegiance is equal to Federation. So if we look at the output of this, if it fails, we see in the Groovy power assert, we can see like the 2-string result of all those spaceships. But we can't really see what was wrong. We can just see false here. And that's coming back to the point I made about diagnostics earlier. That's not super helpful, right? So if we move the allegiance outside of that every expression, and I think the good rule of thumb here is to keep as much outside of every as you can. This uses an implicit collect operator. So that's the same as having star.allegiance. So now we've got a list of strings, and we're making an assertion about a list of strings. If you look at the output from that, it's way better, right? Because we can see the 2 strings of all those spaceships, but we can also see exactly what is wrong, exactly what the bad data is here, because we've done that implicit collect. So think about that when you're again, it's coming back to think about the assertion result, that amber step in the red-green refactor. Grouping assertions by target is really nice. It's similar kind of readability, dryness thing. So here we're finding some spaceships, and we're saying, right, ship.registry.allegiance.class should equal these things. We can group these using Spock's with method. So what that does is say that any Boolean operation inside of this closure, using that as the delegate, is treated as an assertion. This is very nice. It's not the same, don't get confused, it's not the same as Groovy's standard with method, where you would be doing ship.with, because that will not turn it into an assertion. But it's just a nice way of reducing some code clutter. You can even do it, I do this quite a lot, is instead of using a when then, turn it into an expect block and just put the thing you're testing inside of the with, and then you kind of avoid a local variable. You can even use it with mocks as well. So here we've got, we're setting up some mocks somewhere above, presumably. We're saying when we accelerate to warp 7 and then accelerate to warp 9, then the engineering officer shouts at us in a certain way. So again, this engineering officer object is some kind of mock, and we're saying like it should do 1 times a report method on that with a certain parameter. So the with block works with Spock's mocks. One logical assertion is kind of a solid principle thing. So it's like the single responsibility principle for tests. Even, it doesn't have to be one assertion statement, but just test one thing in a given feature method. This is one case where I think a bit of duplication is warranted. Don't reduce duplication to the point where you're testing a bunch of stuff in one test. If you repeat some of the stuff in the given and when, that's fine. Keep the then focused on the meaning of what you're testing. So here we're saying, right, we're testing our DAO object again, and we're saying all the allegiances should be right, but we also expect this to be an immutable list. These are 2 totally different concerns, 2 tests, not 1 test.
Rob, I have a quick question on that.
Yeah.
If you go back to that slide, it seems like this duplication would be a good use case for a where block, right? Like what you were showing earlier with defining the description variable inside of the where block. Could you do the same thing for this? where you could say like the allegiance is federation.
Well, I think what it's really trying to do there is test that that query is selecting properly. So, you're expecting multiple results, but they all should be the right thing that you're testing for. So I don't know how. I'm not sure that aware block really works there.
Okay.
Because the collection is the result of a single call on the object you're testing.
I guess what I'm saying is inside the where block, just defining what that variable is.
Oh yeah, for sure. Yeah, absolutely. Oh, in terms of the documentation purposes, yeah, pulling this string out, yeah,
And then it's
totally, yeah,
Then it's not duplication.
yeah, absolutely, yeah, yeah. But the problem here is that you're testing one thing about whether it's selecting correctly, and another thing about the fact that it's made this an immutable list. It's like two totally different, totally separate concerns. Block grammar is kind of an interesting thing. It doesn't actually matter in terms of how the test runs, whether you use when and then, or given and expect. But think about what your test is telling the reader. So here we're saying, right, we're going to add into the ship's crew. We're going to add, presumably these are some kind of objects representing crew members. We're going to add Kirk, Bones, and Scotty, and then say that the ship has an open position for a science officer, right? But think about it. This isn't, when suggests that this is the action we're testing, adding stuff to the crew. It's not. The thing we're testing is whether this open positions detects correctly what are the open positions on the crew. So the more appropriate grammatical construction is to say, given we have done this, expect this output. So, it doesn't make any difference in terms of how it executes. It works the same way, but just think about it from a readability perspective. Sometimes given and expect is more appropriate than when and then. One of the cases where it doesn't work is if you're testing for exceptions, you have to use when and then. Mocks, I believe, is also the same thing. So, talking of mocks, let's look at some stuff around that. What are we looking at here? So here we're logging in, adding something to a basket, completing a checkout process, and then we're saying, right, our credit card gets charged. This is good. Payment mock is a mock. We're testing one time something happens to it with certain parameters. That's good. Here is a bad example of using a mock where we are, we've got a dummy list of ships. We're mocking our DAO. Then we are rendering something out as HTML, and we're saying, okay, we expect a certain output in HTML terms. We're also insisting that the list method on that DAO gets called one time, and then it returns that list. We don't care if it gets called, right? This should not be a mock. This should be a stub. It doesn't matter if it gets called or not. It's purely there to drive the test. And I think a really good code smell that I look for here, and again, like any code smell, is not always true. It's not a hard and fast rule, but if you're using, like, asserting the cardinality and you're returning something, that's probably a sign you should just be using a stub and not worrying about the cardinality. Again, I can't stress enough, it isn't always the case. There are situations where it's appropriate to be doing that, but I tend to find if you're asserting cardinality and returning something from that stub, chances are you should just be using a stub. So then, and it even reads better, right? So here we're saying, we've got our list of ships, and when somebody queries it, that's what it will get. When somebody queries our mock DAO, that's what will get returned. Okay, so then when we proceed with the thing we're actually testing, this is the output we get. So, it reads more logically. One of the things I really like about Spock is the fact that when you're asserting cardinality of calls on mocks, that comes at the end of the feature method. And when you're using stubs as a way to drive the behavior of the test, it's done before in the given block. Luke Daly taught me this technique, and I had no idea you could do this with expect blocks, but I find it really useful, enforcing preconditions. So what are we doing here? So we're writing something to the database, are we? So we create a new user object, we persist him via some kind of DAO, and then we select from the database and say, right, now there should be one user. Fine, it's pretty basic, but okay, let's think about a slightly more complex example. What if this was this user store used some kind of shared resource? Is it really going to be one? Do we know it's going to be one? Maybe we want to check that beforehand. So one thing you can use expect blocks for is to say, right, before I even do my when block, let's test that this condition holds. This is kind of a goofy example. It's not very realistic, but I've used this for things like I don't know, testing. Actually, there's a good example in a couple of slides of a real world use for this. But you can have given, expect, when, then. So it's just like a precondition. It's verifying the state of the world before the test begins. And here's the real example. This is some code I wrote for Netflix to do with Spring Batch. So the idea here is that if you have a batch job that executes and it completes, you're not allowed to try and restart it, right? It should throw an exception. If it fails, you're allowed to try and restart it. If it completes, you're not. So we kind of have some mocks for the different steps in that job, and they all return successful. Sorry, stubs, not mocks. They all return successful. So when we launch the job, we expect that it runs successfully to completion. And then when we try and resume it, we get an exception. This is kind of important because, like, this assertion is not valid if it didn't run successfully to completion. It's a useful indicator that the world is in the state we expect it before we try and test anything. Good technique to use. Another use for expect blocks. This is accessing previous values with Spock is my favorite thing to show to Java programmers because it just freaks them out. So if you think about your typical goofy stack test where you push something onto a stack and then say, right, the size is 1. Okay, what if it's something more complex we're dealing with here, like a cache, where it's maybe a little unpredictable what the size is before we start? In Java, you would typically capture it in a local variable and then test against that and just say, right, it's now old size plus 1. Spock's way better. You can just say, right, I'll use the old method and show this to a Java programmer, and it just looks like magic, right? If you follow it with a debugger, it's actually really interesting what it does, because the debugger will enter the feature method and it'll jump straight down to this and run this, and then back up to the when block and down. So then it kind of gives the trick away, but it's a very cool thing. I use this a lot. Let's look at some anti-patterns. These are always kind of fun. Evil Spock, you can tell the beard makes him evil. So test organization, thinking about behavior and not units of code. So typically, especially frameworks like Grails tend to enforce this kind of thing a little bit. Don't worry, you don't need to see the details of this code really. They tend to kind of encourage an ordering of a test by the unit of code it's testing. And I think you really need to think beyond this and test by behavior. So it's a fine place to start, organizing things like having a class and then the test for that class. But it can be appropriate to cut across different classes or have multiple tests for a single class. So here we're dealing with some kind of DAO object again, and we're like setting up a bunch of data here in the setup method. Then we've got various tests for different queries that operate in different ways. And then we've got one for like writing some data using that DAO. It never looks at any of this information that was done in the setup. So that's kind of a smell there telling you right away, this probably belongs in a different test class, because it's not using any of that setup. And in the worst cases of this kind of anti-pattern, I've seen where somebody will like set up a bunch of stuff that 90% of the tests use, and then like one test takes half of it apart again, or like sets up some more information that's slightly different, or like deletes a bunch of this data again just to get it working, just to shoehorn it into that same class. And that's just, you're adding code to make it less readable. No, stop, take it out, put it in a different class. Have multiple classes per test, per unit of code, that's fine. When block bloat is always fun, and I see this again a lot with Jeb tests and kind of end-to-end stuff where you'll have when I go to these 3 product pages in order and add stuff to my basket, and then go to the basket page, then I've got 3 things in my basket and it's the right things. But when block, the meaning of a when block in Spock is this is the action I'm testing. And that's not what we're seeing here. We're just kind of seeing a whole bunch of stuff that happens. This is the action we're testing, this one line. When we go to the basket page, we see the certain results. So, this stuff should all be moved into the given step. And it's an easy trap to fall into, but, you'll see some when blocks that go on for tens of lines. And it's just, it's wrong. And especially, it really helps when you're using things like old and when you're using mocks to isolate that behavior down to a very simple case. The when should be super small in 99% of cases. Tautological tests are kind of always fun, where you're testing the result of something using the same mechanism that the code actually uses to generate the result, so it can never fail. So here, like we're testing a DAO result by comparing it against a query that's probably the same query that this DAO is using. So like if the query's wrong, it's never going to fail, right? You're never going to see, and it's not a great example because I don't think anyone really would be stupid enough to do this, but it can actually be quite a subtle thing sometimes where you don't realize that all you're doing is proving that A equals A. You're not proving that anything actually works. You're comparing dummy data with dummy data, or you're comparing a mock implementation with a mock implementation. And interestingly, overusing mocks is kind of another example of this, a little bit where all you're really proving is that your mocks work in certain tests. You're not really exercising any actual behavior. False moniker testing is a fun one where you kind of, instead of testing behavior, so here we're like adding some spaceships into a list or some kind of, let's say that's some kind of DAO, this will insert them to the database. Then we're doing a query and saying, all right, yeah, I'm going to query by allegiance newest first, and I want all the Federation starships. And yeah, I expect these 3 to come back. But if we look really carefully, this logic is wrong. So it's supposed to be newest first, and actually the order is incorrect. And this one isn't a Federation starship. But it's not obvious that that's the case because we've just put these names in here, these false monikers. These are like labels for the data we're expecting. We're not actually testing the real behavior. And this, especially in end-to-end tests, is a really easy trap to fall into, where the test is just misleading because it looks like, okay, we're just going to test some fun data. And this is another thing. Developers love to put fun data into their tests, right? And that makes you fall into this trap really easily because you'll test your hilarious news headlines or something like that, but you find yourself not really testing the behavior properly. So instead, use something that says, right, every allegiance is Federation, and then when we sort the list, it comes out in the correct order. It compares correctly to the list we got back, and the order is the same. Instead of just using these labels representing what you think you should see. Interrogating external state, I don't actually have a good example here, but treat your code under test as a black box and use its API to test it, not reaching under its skirts and trying to fiddle with private variables or anything like that. Just no. Fail fast assertions is always good fun where, okay, what are we doing here? We are saying we can identify numeric strings, so all of these strings should evaluate as number. What happens if one of them doesn't? In fact, one of those doesn't. If we look at the test output, what do we get? False, not very helpful. That's an example of a fail-fast exertion that's effectively using a loop instead of a where block. So structure it as a where block instead. Another type of fail-fast assertion is kind of the run-on test where you can have when, then, expect, when, then. You can repeat when and then pairs as many times as you like in a Spock test. But like if this one fails, none of this logic happens. So you can get into this horrible cycle where you fix one thing only to move on to the next failure. You're never seeing the entire test output at a single time, and that's something to try and avoid. Just try and execute everything at once and not just selective part of the test. And another special case of this is Spock's stepwise annotation, which is very powerful and can be very useful. What it does is it executes each feature method in sequence, and if any one of them fails, it stops, and the data doesn't get torn down in between them. And for performance reasons on end-to-end tests, particularly, this can be really useful. But it's also kind of an anti-pattern. So it's something to be used. It's a tool to be used with great care. If it's really justified for performance reasons, fine, go ahead and do it. But remember that if step 1, test 1 fails, none of the rest execute. So if you've also got a problem in test 2 and 3 and 4, you're going to be sitting there quite a long time rerunning stuff and fixing individual steps in order to get through this. Sometimes it's a trade-off worth making, but it's something to try and avoid if at all possible. Let's look at some kind of slightly less usual ways of using Spock. TCK specifications is something I really enjoy. I did some of this recently at Netflix where I'll get to why in a second, but we use an abstract class that's it may or may not need to be parameterized by type. So we're saying our subject is this parameterized type. It's not a concrete type, and then we're going to write a bunch of tests against that type. I used this for testing some Spring Batch stuff. I was writing a different implementation for the persistence layer, and I didn't really know how the real one was supposed to work. So I ran the same tests against the real one and my one that I was writing, and then I could see like if my tests are wrong if it's failing against the real one, and my code is wrong if it's failing against my new implementation. So then you can extend that abstract base class and just set up. All you need to do is set up the subject. Here we're setting up a really simple in-memory DAO. Here we're setting up a slightly more complex one that's actually using a database, but it's extending the same base class. And when you run it, all of the tests run against both implementations. This is the killer use case for traits, I think, because the way you can do it at the moment is with an abstract base class. Being able to mix in tests using a trait would be fantastic. So you could kind of extend it. Maybe one of these implementations does some more stuff you want to test tests that are only applicable to a single implementation. So then, yeah, you don't have to repeat the test. You write the test once in the abstract base class, and they run against all the different implementations. Great stuff. Data-driven parameterization, going beyond hard coding the data in the where table. This is a real example from a project I worked on a few years back where we kept screwing up indexing on our database because we kept forgetting to add primary keys to tables. So we added a test that just said, given a database connection, assert that a particular table has a primary key, and we drive the where block using a list of table names. So where does that list of table names come from? Remember that a where block can be driven by anything iterable. What we did was set up a list iterable string of table names in the setup spec method here by reading the database metadata. So we just list out all the tables and add them into that list. And then the beauty here is that if somebody adds a new table to the system, we don't have to remember to update this test. It just goes ahead and checks that thing has a primary key automatically for free. No test code gets touched in order to achieve that. I've seen some similar things done with things like static site generators where you're testing like HTML gets output in a certain way, and you probably want to be reading the file system and using that to drive a where block, that kind of thing. Anything iterable you can drive a where block with. It doesn't have to be hard-coded within the test itself. Databases and file systems are the typical case. This is a nice thing. There was a great post by David Norton from Object Partners about testing JavaScript with Nashorn. So it's really very simple. You can set up a script engine, specify Nashorn, load in some JavaScript library here. I'm loading in the Moment.js library, which is kind of a date handling library, a bit like Yoda time for JavaScript. Load it into the script engine, grab hold of an object representing that JavaScript object, and then we can use a typical spot clicking test against it, right? We can use a where block. We can say, when we invoke this method using a particular object here, we get an expected result out. The nice thing is that Nashorn is such an awesome script engine. You can pass any kind of Java object across that divide into JavaScript land. Now you can pass Spock mocks, and all the assertions about cardinality work. You can pass anything in there. Back in the days of using Rhino, you had to do this horrible kind of turning everything into JSON and then back again on the other side of the language divide. Not the case in Nashorn. Dan does an interesting talk that touches on this stuff about how good a scripting platform it is. The fact that you can throw a Spock mock into a JavaScript method and use it to test it is a lot of fun. And Spock's the best mocking library around, so it's a really good way to go. Some simple, cool features just to finish up with. Unrolling parameters, so you can use a double pipe to separate your kind of logical inputs from your logical outputs. That gets forgotten a lot. If you're using IntelliJ, be careful, because if you have multiple columns on this side of the double pipe, it doesn't format correctly, but I'm sure they'll fix that sooner or later. What are we doing here? So here, remember, you can, if you really need to, you can put actual formal parameters on the method when you're using a where block. In cases where the types may not be inferable, like here we're driving our where block using a database query. and just loading in 3 different variables, and your IDE is not going to be able to figure out what type those things are. So if you want any code completion or that good stuff to work within the body of the test, it's probably a good idea to put the types on the parameters. And this is all Spock is doing with an AST transformation under the hood anyway, so it's just adding parameters to the method. Conditional tests is quite fun. You can use ignore if, or in Spock 1.0 snapshot, you've got requires as well, which is kind of the inverse Boolean wise of ignore if. You have some magic variables. You've got Java version environment variables and system properties. So, I've written tests before that were testing for some weird condition that only happens in Java 7. Or, if you're using something that's using the java.time APIs or something, you may want to only run those tests if it's Java 8 or above. Environment variables are pretty typical on CI, particularly for running things in slightly different ways, using different versions of browsers in Jeb and that kind of thing. And, you've probably got some tests that are way too slow to run in IE, so you want to skip those if you're running IE because you run most of the stuff in other browsers, but other ones that are testing because IE always screws something up. They're testing very specific things. And a real-world case I did of this was because I'm working remote from London most of the time, and I'm not on the Netflix network. I wrote a smoke test that was kind of connecting to the bakery and a bunch of other things, and it wouldn't work unless I was logged into the VPN from home. So I added something to say, right, don't run this test if I can't reach, this Netflix URL. And I wrote a dumb little function that just tries to ping that URL. If it can't get a response within a second, it gives up and returns false. But something to be aware of is that, these things get evaluated on every test you add them to. So, what happens if I use this is reachable method on a multiple tests? I'm killing a second for every test. So remember, use Groovy's memoized. So it only then will run it once. It's still a performance hit, but it's probably acceptable. JUnit rules work in Spock. There are a ton of them out there. Here we're using a temporary folder rule that ships with the core JUnit library, if I remember right. It just works in Spock the same way it would in JUnit. The only weird thing is that, I tend to try and avoid this kind of duplication of type information in Groovy. On the left and the right, you have to specify the type of the variable for a rule to work. I don't even want to try and figure out why that's the case, but you do. Hamcrest matches also work. They tend not to be super useful a lot of the time because Groovy's power assert is so fantastic at getting you good diagnostic information, but sometimes grammatically they can be useful for just composing things that you would have to do with multiple assertion statements. So you can use this expect method, which is statically imported from a Spock library, and then you import your Hamcrest matcher. This is an interesting case, actually. I had a long-running discussion on Twitter about this, about how to assert if you've got a list or a collection that can have a cardinality of greater than 1 of any given element, but you don't care about the order. What's the best way to do an assertion of that? And I got a bunch of different answers back, some of which actually weren't logically correct. And didn't assert properly. So in the end of the day, I found the neatest way is to actually use this contains in any order Hamcrest matcher. It's much more readable than kind of sorting both sides of the expression or some weird thing like that. So it's purely saying expect that this value evaluates to true against this Hamcrest matcher here. Works just fine. And grammatically, you'll see we're using the expect method there. If you're in an expect block, you probably want to say expect that this condition holds true. That is just another statically imported method from the Spock API. Does exactly the same thing, just reads better in an expect block, because you wouldn't want to say expect. It doesn't make any sense. So it's just an alias. Cleaning up resources you may have seen. So here we've got we're opening a database connection, we're setting up a DAO. In our setup, we want to create a database table, and in our cleanup, we want to be sure we drop that table and close our database connection. And obviously, order is important there. We can use Spock's auto cleanup annotation to just neaten that code up a bit. By default, that will look for a method called close on the object and call it automatically. If the method you need to use doesn't happen to be called close, you can specify what it actually is called, and then we've removed the need to specify a cleanup method there. And importantly, the order this happens in is reverse declaration order. So it's actually deterministic, which kind of, in this case, is key. So it'll drop the table before closing a database connection. It would be pretty disastrous if it did that the wrong way around. So that is deterministic with Spock. And my clicker's gone to sleep. Oh, and yeah, auto cleanup works fine with shared. Things are annotated with shared. Just the cleanup happens at the end of the entire test after all the feature methods instead of after each individual one. But it works just the same. Just to finish up with one stupid Spock trick that I came up with. I tweeted about this, and a load of people were like, "Oh yeah, that's an awesome idea." And I was like, "No, I didn't mean it. I didn't mean it. Don't do this, really." So you can use Groovy's import aliasing to use import void as should, and then you can say, "Oh, should exhibit some behavior as your test method name." But it was a joke. Please don't. I was disturbed by how many people thought that was a good idea.
We're going to Groovy West Void, I think.
Really? Oh God. Yeah. Sorry. That's my fault. Right. So with that, I'm done. I went 5 minutes over, but that was 108 slides in 50 minutes. So I hope that was useful. And please fire away if you've got any questions. Otherwise, go grab a beer and speak to me afterwards or whatever. But thanks for coming, and I hope that was useful.
Java Twitter account retweeted that tweet that you made about that.
Yeah, they did. Yeah.
Like a million person reach or something.
Yeah.
I looked at an earlier version of these slides, and I didn't catch that was a don't.
Yeah, that's the problem. Like the slides here just don't work out of context of me actually talking over the top of them. So like half of what's on these slides is like examples of how not to do stuff. So yeah.
So I put it into it, and I did a great con, and then someone came up to me and said, "Rob Fletcher said you shouldn't do that."
Okay.
So yeah, if you have questions, comments, obviously he wants to grab a beer, so let's have some beer.
Feel free to.
We have the theater for another half hour, so I will update the meetup site for next month's meetup. Stand by for that, and once again, thank you very, very much for coming tonight.
And you'll tweet the link to the video.
Yeah, I will tweet the link. People here at Netflix hopefully will retweet it. I'll also post the link of the video on the meetup site. Give me a couple days because the video people here at Netflix need to edit it and whatnot, but it'll be posted and we'll get it out there. So thanks again for Rob for joining us tonight. Really appreciate it.
Thanks.